Hi, Erica, are you online?
Hi, I am.
All right, there you are.
Okay, can you hear me okay?
Yep, we can hear you. Go ahead.
Right. So I'd like to start out and say thank you to Maud for hosting this event once again under these changing circumstances. We look forward to seeing everyone in the future in person and hope that you guys will connect in our networking session later tonight. I'm Erica Halstensgaard with Houston Engineering. Here are a few of the projects that we're presenting on today: the Hanson Park in the Rice Creek watershed, Black River Impoundment in the Red Lake watershed, and then this session is about the Hallock Dam retrofit, which is in the Two Rivers watershed. We'd like to thank all the watersheds for all the work that you do in protecting our water resources and in our communities. Here are some of our clients that we worked with in the watersheds within this year. We'd like to thank them as well for giving us the opportunity to collaborate and come up with different solutions that are positively impacting our communities. With that, I will turn it over to Ted Rude.
Thanks, Erica. I think rather than bore you with a bunch of other engineering stuff, we'll get right into the presentation. We are presenting on the Hallock Dam retrofit, and like Erica mentioned, that's in the Two Rivers Watershed District, and the client for that's actually the city of Hallock. So Erica, I'll let you take it from there.
Yeah, so Ted just mentioned we worked for the city of Hallock. There's a few different funding sources for this project: the Lessard Sam's Outdoor Heritage, U.S. Fish and Wildlife, the Minnesota DNR, and then the contractor for this project was Spruce Valley. So now the project location, this is located within Kittson County, which is in the northwestern part of the state. Hallock is located pretty centrally within Kittson County itself. And then this is where a majority of our project took place within the city of Hallock. We also did some riffles downstream. This kind of just shows an overview of where Hallock is located within the Red River Basin. So as you can see, it's about 12 miles upstream of where it enters the Red River, where our project took place. So then this also is zoomed out a little bit more. It just shows where Hallock is located. And then Lake Bronson is the dam upstream. So we were connecting with fishways, so fish are able to swim from the Red River upstream. So we connected about 30 miles between Hallock and Lake Bronson, which was located on the Two Rivers in the South Branch.
Like Erica mentioned, one of the biggest components of this project was to restore the fish passage across the dam. There's about 12 feet of fall from the crest of what was the existing dam to the channel bottom downstream. So in order to get fish up there, we had to construct some rock fishways. And before the project was started, the DNR had done a fisheries survey, and there were about 43 different species of fish that were located downstream of the dam, and only 13 species of those were located upstream. So the hopes are that after this project's complete, that a lot of those other species will be able to make their way upstream and kind of get into that extra 30 miles of fish habitat. This is just a project overview. The main components of the project were the upper and lower rock fishways. In between those, we also kind of beefed up and reshaped the channel slightly between them with a towed debris bench. We did do a little excavating on that inner toe to make it more of a gradual bend. In addition to that, we kind of installed a better overflow spillway. The current one saw a lot of erosion. And as part of this project, we had to create a kind of a cart path that went across that. And so that acts as the crest for the overflow spillway. Another unique kind of component of this whole project is that the city of Hallock, their golf course is actually located right across the bridge from the basically on the south side there, and that's their main access point to get to the golf course. So we had to do some working with them on timing and construction of the bridge that goes across the upper rock fishway to kind of keep them in operation. And kind of the last component of this project, we planned for being able to install up to 7 riffles, and a lot of that depended on how much funding was available. And kind of throughout the construction, we ended up doing a few different things where we were able to install 2 of those 7. So we kind of picked the more critical ones for this upstream and for this downstream of our proposed locations. And with that, we'll probably jump into the fishways. So kind of a unique component on this project was that there was a pretty tight bend in the channel right downstream of the existing dam. In order to work with that, we had to kind of break it up into 2 different rock fishways. And it actually worked out pretty well because the lower rock fishway ties into where the existing concrete spillway is located. It's kind of hidden behind some of those trees that are on that photo to the right. But that overflow spillway is actually used quite frequently. Most of the spring runoffs will actually hit a level upstream where they'll actually flow into that concrete spillway. And then the drop across both of the rock fishways, it's about 6 feet in elevation. I think we had to do about 12 feet total. So here's just kind of a design layout of what the rock fishways look like. You know, there's a lot of riprap in there, and for the flows, we try to create these pools, and in order to do that, we construct these rock weirs, and they're kind of this example just kind of shows more concave shapes to them, but we actually add a little more wiggles into it and try to create these pockets or these pools so that as fish are swimming upstream, they can kind of get into one of these pools and hang out for a little bit, kind of catch their breath, and then use their little burst speed to get up to the next one. Each of these rock weirs, we like to kind of gradually step down. So typically the design of them, you want to stick between around 0.4 to 0.7 feet. I think this project, we were right around 0.6 for most of those. And as you get kind of further or closer to the crest, you want to kind of start burying them into the rock fishway, so that way the very upstream one is pretty much flush with what that crest would be.
So this is just showing an example of those images we had showed, but with the actual riprap installed. So as you can see, this green line is one of those weirs, and then this is just showing how that flow is forced to come into the center of the channel. And then this is looking upstream, and you can see how it's stepping over some of these weirs. So for the fishway design, we like to start out with having a base for the rock. So we use a little bit smaller rock. It's a class 2 size riprap, which means it's 12 inches and smaller. Our thickness here that we used was 18 inches. And then in order to keep that flow on the top of the rock surface, we added in this aggregate mixture. And for this, we installed this class 2 riprap, and then we put it over the top, having it kind of penetrate down through the rock. And then on top of that base, we use a class 5 riprap, which is a little bit bigger. The max size of this is 30 inches. And then for this, instead of just installing that aggregate mixture on the top, we actually were incorporating it throughout. When they're placing this riprap, they had it mixed with that aggregate as well. And then those weirs that Ted was talking about, where it kind of creates a pool. So those are large rocks, anywhere between 3 to 6 feet wide, that we used.
So this is just kind of showing the layout for the upper rock fishway. As I was kind of mentioning before, some of those rock weirs, we like to kind of add some wiggles in there so you can kind of create pools as you're stepping upstream. Typically the very furthest upstream rock weir, we usually do more of a concave shape to it, and that one's kind of buried within that class 5 riprap. So that way the crest is about the same with the rock weir as the rest of the fishway. And then that furthest downstream rock weir, we also kind of like to do more of a concave shape to that one and really kind of use that to help direct flows towards the center of the channel as you get even further downstream. As far as the grades go for this, most rock fishways typically do better if you can keep them at a flatter slope. So for this one, we had 3% slope that we used. And then, spacing between those rock weirs in order to kind of keep that 0.7 feet above, we did about 20 feet, and that kind of varies obviously as you have some of those wiggles in the rock weirs. They get closer and further apart, so we tried to keep them at least 5 feet apart, but 20 feet was about the average distance we did for kind of stepping down through those. This is just showing kind of the construction around that outer bend. This is located between the upper and the lower rock fishway. And here is where we installed the towed debris bench. I don't know if you've ever seen the installation or process of installing towwood, but it's kind of interesting. You have to actually go and harvest live trees, and usually you cut them off about 15 to 20 feet from the base of the tree, and you basically try to tip them over and keep that root wad intact. And that root wad's a pretty important component because that creates a lot of the erosion protection within the channel. So what the contractors will typically do is they'll grab it with their backhoe and kind of pull that trunk and jam it into the bank. And they'll be kind of crisscrossing these the trees over one another with that root wad kind of sticking out into the channel, and that really helps to slow the flows down as it's going around the outside of the bend, which helps to prevent erosion. And then a lot of that kind of woody debris material can be kind of packed in alongside of that and also jammed into the bank. And then they like to go and kind of spread some dirt, kind of flatten it out a little bit, and then put a sod mat on top. And on the right, you can kind of see where we've installed some of those sod mats. If you can find, anything that has willows or something with a little bit longer root system, that just really helps to grow down into those the towwood and kind of help hold everything together. And then another kind of issue alongside this outer bank is that there was a lot of kind of sloughing of the bank further up. During a lot of the flooding times, a lot of this area, it's pretty channelized downstream, so it fills up quite a bit, and they've actually seen some erosion issues up there. So the landowner in this case had some concerns with the bank stability. So this one, we actually did go in and install some additional riprap to kind of line that bottom portion of the towwood and kind of help hold that bank in place a little bit better. So this is one of the riffles that we installed. We installed 2 during this project. Like I mentioned before, we were planning to be able to install up to 7 if we had enough funding. But there were a few things that we decided to change during construction. One was probably the more important one was where the lower rock fishway ties into that existing concrete spillway. For that one, we decided to bring in some more rock to help better connect it to prevent erosion as it's leaving that concrete spillway and entering the channel. So the design for these, again, it's kind of a concave shape, and it's really meant to direct flow to the center of the channel and kind of create more of a pool on the downstream end, which one thing it does is it helps to kind of stabilize the grade. And looking at the south branch of the two rivers downstream of our project, there wasn't too many stability issues. It was, relatively flatter channel, but this helps to, ensure that it's not going to be cutting down. Then also to kind of create more of a pooling area for fish to kind of hang out in. Some portions of the summer, like this summer especially, the river will actually kind of stop flowing right at the dam. And so it's, creating some of those pools where fish can maybe hang out until there are more flows in the river. The picture on the right is from this year. This riffle was installed last year. And you can kind of see how some of that sediment's kind of settling out within the riffle itself, and kind of holding it all in place.
So another design component for this project was the bridge that would connect the parking lot and able to go to the golf course on the other side. So we ended up doing a single span beam bridge to reduce the potential for log jams and ice, where before the existing bridge had two piers in the middle of it. And then also this design, our 100-year is able to pass underneath the bridge without hitting the bottom of our beam, where on the existing bridge at a 100-year event, it was overtopping the deck. So you weren't able to drive. And then this shows we ended up doing, we have a black railing and then a rub rail, or it's called the timber rub rail. So this is for golf carts to travel over. And then the next component, we did a cart path that connected this parking lot, and then it connected over up to the bridge. This was used for a few different purposes. What Ted had said earlier is this is acting as a set control for the overflow. And then, so it comes over this path and then through this vegetated area, and then it enters the existing concrete spillway. As you can tell from these pictures, we ended up putting riprap on both sides just to help with those velocities of when the water starts coming over.
So this project was pretty unique, and it had some different design challenges that we had to deal with during the design and construction of the project. The access to the Two Rivers Golf Course was one of them. There were some timing concerns and keeping the golf course open during a lot of their season. Another was the runout elevation of that upper rock fishway. So the city was pretty adamant on having it about a foot higher than what was the current runout. So we had to kind of work with a few different things on being able to do that. The river bend downstream of the bridge that I talked about earlier, it was a pretty sharp bend. And so we had to do a few things to take that into account during the design. And then the modifications to that overflow spillway, we had to lower that and widen it in some locations in order to keep the capacity for the 100-year from increasing water levels upstream.
So as Ted had mentioned, the access to the golf course was pretty important. Their golf season that they use is May through September. So what we ended up doing was we started construction in October, and then we ended at the end of December, and then we started up again in March, and we were able to be done by May 13th. So they were able to have the access that they were concerned about.
So the picture on the left here shows kind of what the dam used to look like, and this is as they're demolishing it, so there's no more railings shown on the deck, of course. But so one of the things that had happened sometime after the dam was originally constructed is that the city came in and they actually installed some caps on a lot of the stop log piers so that they could raise the water level even higher than what the original dam had been constructed for. And I'm not sure if there was some miscommunication during that process, but I don't think the DNR was involved with that decision. So over the years, they had operated at a slightly higher level. And then over time, due to some of the log jams and ice jams, some of those concrete caps had actually broken off. So it hadn't been operating at that level for probably 20 plus years. But the city, they have kind of a park area located right along the river in this location. They have a boat launch that's just upstream of the dam, and they were pretty adamant, creating a better swimming hole and keeping the water level higher, that they wanted the runout to be raised back to where it was, 30 some years ago. So in order to do that, it was a little bit difficult. We had to work with the permitting agencies, the DNR, on being able to show that we weren't going to raise the water levels upstream of the dam. And for events that we did, we had to obtain easements. And so one way we were able to accomplish this was to kind of widen that overflow spillway area. And Eric had mentioned we rip-wrapped on both sides of that cart path to kind of help prevent erosion. But we basically had to widen a lot of that. And in doing so, we were able to create enough capacity through there where only some of the smaller events were impacted. I believe anything less than the 10-year event would actually see a slight increase in water surface elevation upstream. So, we ended up raising the runout from what it was by about a foot. So we ended up getting easements for all the landowners that were impacted upstream of the dam location, and then we were able to increase the capacity through that overflow spillway so that the events above the 10-year didn't see any change or were slightly improved.
So this was one of the concerns, I guess, was coming around. This is where the bridge would be, is you come around, then you have this tight bend. So in order to accommodate that, we did a few different things, that tow wood installation that Ted had mentioned, and then also the two fishways were designed so that this water in between here was acting more as a pool, so that it would slow, once it's coming off this upper fishway, it's going to slow that velocity down quite a bit, instead of how existing conditions, it just came around quite a bit faster. Also, this lower fishway, it's kind of hard to tell from this picture, but this is where that existing concrete spillway connects in. So we had to be able to design those to all connect as well. And then this is the overflow spillway. This is where we made that quite a bit of modification, where it's longer and it's we set that elevation to what we wanted as the overtopping for the channel. And then there was some erosion that was existing happening right here, which we have it in a picture coming up. So the modifications we made for this, we had this cart path set and then riprap on both sides. So water is going to flow over and enter this spillway. For a 10-year event for the proposed condition, the city has a temporary bridge that they can put over this spillway. So you're able to come down and drive over that bridge and you're able to still get to the golf course, even though water might be overtopping this over here. Now we have some pre and post projects of different locations. The pre projects are on the left and then our post ones are on the right. So this would be looking directly downstream of the bridge. So on the existing conditions, they did have some riprap, but you can see there's a hole here. And then this is our, what we call the upper fishway. And you can see how it's stepping down. And then we have these pools in between each of the weirs that are probably 2 feet deep approximately. You can kind of tell from this picture as well, each of these weirs are set of either between 6 and 12 inches apart so that fish are able to swim through here to get up to that resting pool. This would be looking towards that bend. As you can see on existing, they have a bunch of debris and sandbar where we ended up cleaning that out. So now it's an easy transition. So this is downstream. This is where that existing concrete spillway comes in. You can see there's a sandbar. They got quite a bit of debris. So we put this fishway in where it's able to step down nicely.
And around this bend too, we ended up excavating part of that inner channel so that we could have a more gradual turn as you're going around. And this is one location where they've had a lot of issues with, debris piling up. I guess there's only so much you can do to help combat that. And obviously by removing those piers, that's going to help keep the channel open where logs and whatnot flowing downstream can actually pass through there during higher flows. But as far as kind of going around this bend, there was a pretty big point bar coming out and a lot of trees and debris were getting snagged and kind of piled up there. So we're hoping that by kind of improving that pool area in between the two rock fishways, it's not only going to provide a place where fish can kind of hang out and chill as they're working their way upstream, but also provide a good area where some of that debris can kind of make its way around that corner and continue downstream.
And then, so now this is looking back up at the bridge during construction, where before we had the dam, and you can see the difference that it made to have it at a similar elevation than having it step down. This is kind of looking at that bridge deck. As you can tell before, I mean, this was a pretty small area for them to get their carts through. They said that there was maybe an inch or two on each side. So we widened that out quite a bit, gave them a little bit more room. And then you can see here, there's also steps that go down to a gravel parking lot in that area. So now if people are walking, they're able to come up those steps and walk through to the golf course if they need.
Yeah, and another component too with the access to the golf course is we need to make it ADA accessible. And in order to get the clearance for the 100-year flood, we had to raise that cart path up quite a bit, which also kind of didn't work in our favor as far as trying to keep the flooding events upstream from being impacted. So that was kind of another reason too, just that extra fill to build that cart path up that we need to kind of widen out and expand the capacity for that overflow spillway so that way we can keep the water levels from increasing.
Mhm. And then this is looking where the dam was and up at the existing and proposed bridge where now we have that weir that's within our class 5 riprap. As you can see here, that's holding the crest. This is looking at that overflow spillway again. So this picture would be actually taken from at the bridge. This is that existing scour that was happening right here. So as part of adding this cart path, it also helped stabilize that existing erosion that was happening. So we ended up filling this in, and then we put some riprap on the outside edge as well to help protect it a little bit better.
Yeah, maybe if you want to go back to that
Go
last
back.
one more time. Another concern too that the city had brought up was the use of that overflow spillway, and they had observed obviously this erosion that you can see on the bank here, but then they also had some erosion upstream of that concrete spillway where they had previously placed some riprap. We tried to design kind of the crest of this to be a longer length across that cart path, with the idea that it's kind of a broader crest where the sheet flow across it isn't going to be ripping through there at a higher velocity. And then it actually worked out pretty well for us this year, with it being a drier summer, that it wasn't utilized at all after the construction of it. So we were able to work with the city, and once the contractor got it seeded, the city actually watered it the whole summer. So there's actually a pretty good stand of grass there now, kind of in between that cart path and where that concrete spillway is. So that's one thing that, going into the future, the city is going to kind of have to keep their eye on. And if, it's pretty broad area that flows to that concrete spillway. So the hope is that, by leaving the grass long through that area, it'll help prevent erosion and any down cutting that might occur. But if some issues arise, next spring, they can always go in and maybe add a little more riprap if there's certain locations that need it.
So this is some drone images during construction. So this is kind of that scour we were talking about on the existing. And then as you can see here, those piers, we have them cut off, and then we poured that concrete wall in between here. And then this is that same day. So you can see the bridge abutment getting formed up, the footings over here. They have their crane. They have their base of the class 2 for both the fishways. You can see here, and then you can see they have that aggregate mixture, and they had just begun placing that larger class 5 riprap as well. And then here they're putting some topsoil behind that tow-wood debris bench. Now we have, so this is a little bit later during construction. It's going to go through a video, and we can kind of just talk through it while it's playing. So this is the upper fishway. They have that class 5 riprap in, and then they've started installing part of these weirs with those big boulders. You can see once it starts playing, those gaps that we were talking about for fish to be able to swim up from one pool to the next. Then now we'll be coming around this curve, and then you'll be able to see the tow-wood debris.
You can kind of notice too further up the bank where there's some sloughing issues. And so when we put that topsoil up there, we also added some soil to kind of slope it up into there a little bit to help combat that. And then in addition to that tow debris bench, which connects all the way from the upper fishway, ties into that riprap there, it goes all the way downstream and ties into the lower rock fishway. We kind of beefed that up with some additional riprap down into the channel. And the hope is that that's going to help support some of that bank weight.
So we're comes pretty fast through here, but now, so you can see how this is pooled up water behind that lower fishway. And I guess it got cut off a little bit, but this is that existing concrete spillway. So you can see we added more riprap on that side of the fishway so that it connects a little bit easier.
And it was hard for us to tell right away too, because there's so much sediment that was built up on the end of that concrete spillway that we weren't able to survey it to the full extent to know where it ended. And it actually gets to a certain point and then it kind of tapers down into the channel. So when they were out there working on it and they removed some of that sediment, they were able to determine that, you know, it would make more sense if we added some more rock to kind of help tie in better to that lower rock fishway. So all that, which actually works pretty nice because all that concrete spillway will now empty right into this lower rock fishway, which will help with future erosion.
Now it's gonna play again. All right, and then with that, do we have any questions? I see there's some in the chat.
Yeah, so I see there's one from Jim. Is there a plan to perform additional fish studies to determine how many additional fish species are now available to migrate upstream of the dam? I believe that's the intent for the DNR. I think it'll be pretty interesting to see, you know, of those 43 species, how many of them actually return upstream. I know on similar projects that we've done in the past, even a year after, 25 to 50% of those missing species have actually been able to make it back up and get documented. And, you know, maybe there's more, but they just weren't caught in their nets. So that'll be something we'll definitely be keeping our eye on. And I see there's another question from Jim. Was there sediment accumulation behind the dam that required removal, or were you able to pass existing trapped sediment downstream? So upstream of the dam is actually fairly deep, so there wasn't really a need to remove any sediment. We did kind of build that upper rock fishway out a little bit, and I think we had about a 10-foot kind of flat crest area, and then we tapered that back down at a 4-to-1 to the existing channel. So that'll help to maintain kind of that crest. Another thing we did do that I don't think I mentioned was for that crest, we cut down the existing dam, but then in between the stop log bays, we actually did pour a concrete wall that was about a foot lower than what the crest runout is, and so that's just going to help prevent any kind of seepage through the rock fishways during dry summers like this, where a lot of that water would actually maybe start drying down some, and then left a foot on top where we can kind of hide it and cover it with the rest of the rock fishway. But yeah, there wasn't really any sediment that we had to worry about just upstream of the dam.
Do we have any more questions? You can unmute yourself at this point and ask a question, or you can use the chat function. Okay, I don't see any more questions coming in. So at this point, I think we can close out this session. Thank you so much, Erica and Ted, for giving this presentation. And I am going to get ready for lunch here. We do actually have an awards ceremony over lunch, as well as the movies that we'll be playing. So if you are interested in watching those, you can actually just stay on the same track that we are currently on. Otherwise, yes, go grab something to eat, and we will see you guys back here at 12 o'clock. Thank you.
Thank you.
Thanks, Maddie.